All right, so in this video, what we're going to be talking about is the angle of elevation and depression. We're still referencing right triangles, so we will be using right triangle trig. In this video, I'll be going through a few examples to guide you through your notes. So let's look at number one. A fire started at a campsite located 8 miles from the base of a mountain. If the angle of elevation from the fire to the top of the mountain is 14 degrees, how high is the mountain? So let's start by drawing a right triangle. So here, the fire started at a campsite located 8 miles from the base. So if the fire is here, right, that's a great looking fire. This is 8 miles from the base of a mountain. The angle of elevation, now elevation means to look up at something. So if the angle of elevation is 14 degrees, I want to know how high the mountain is. So if I want to know how high it is, I'm looking for its height or its altitude. So here I have the opposite side. So if I draw this, because remember, directly across from the angle is always the opposite side, and then the leg that touches the angle is always the adjacent leg. So I have opposite and adjacent. So I need to think, okay, which trig ratio should I be using here? Sine, cosine, or tangent? Well, opposite and adjacent belong with tangent. So here I will say tangent of 14 degrees equals the opposite leg over the adjacent leg. I want the value of x, so this is x being divided by 8, so I have to do the opposite of what they're doing, so I will multiply each side by 8. So here, 8 times the tangent of 14 will equal x. So what I'll do is I'll come down here to my calculator. I will make sure that I am in degree mode. You will not need radians. And I will say 8 times tangent. Let me make sure I have my angle right. That is 14 degrees. And there's my answer, 1.99. So we're approximately 2 miles away. So here I can say approximately 2 miles. So on number 2, it says a man is standing 85 meters from the base of a tower. If the tower is 200 meters tall, find the angle of elevation from the ground where the man is standing to the top of the tower. So again, we're going to start by drawing our right triangle. So they tell us the tower is 200 meters tall, and the man is standing 85 meters. So here's the man. He's standing 85 meters from the base. They want us to find the angle of elevation. So here, if I label my sides, directly across from the angle is always going to be the opposite leg. The leg that touches the angle is always the adjacent. So here again, I have the opposite and adjacent legs, so I'm going to be working with tangent. So tangent of this angle should equal the opposite leg divided by the adjacent leg. Now remember, you can't simply just divide by tangent here. Tangent is a function. So what we need to do is to cancel out this function. So the way you do that is you would multiply it by its inverse. So if I do it to the left, I also have to do it to the right. So I'll take this fraction, move it over just a bit, and now I will multiply this as well by tangent inverse. Now, tangent inverse times tangent will reduce to 1. So now x will equal the inverse tangent of 200 divided by 85. So I'll do that on my calculator. Again, making sure we're in degrees. Here you see tangent, and then right above it in blue you see inverse tangent. In order to get that, make sure you're hitting the blue key, second, tangent, and we're going to type this ratio in. 200 divided by 80. I'll double check to make sure those are right. All right, so it's 85 actually. So let me go back. 85, and I can hit enter, and then there's my answer, 66.97. So that would be our angle of elevation, 66.97. Since it rounds up like this, we can pretty much say that that's going to be approximately 67 degrees. So here, this angle, X, is approximately 67 degrees. All right, we'll look at a few more. So a 32-foot tall ladder rests against a vertical wall. If the top of the ladder reaches a point 18 feet up the wall, what angle does the bottom of the ladder make with the ground? All right. So here we'll draw a right triangle. They tell us a 30-foot tall ladder rests against a vertical wall. So if I'm talking about a ladder, that's going to be my hypotenuse over here. The top of the ladder reaches a point 18 feet up the wall, so my wall is 18 feet. What angle does the bottom of the ladder make with the ground? So we're looking at this angle here. So I can go ahead and label my sides. Directly across is the opposite. Across from the across from the right angle is always the hypotenuse. So if I have opposite and hypotenuse, I should be using sine. So sine of my angle should equal the opposite, 18, divided by the hypotenuse. Well, again, I don't want sine of the angle, I just want the value of the angle. Well, this angle is being plugged into a function of sine. So we can't just simply divide by sine or cross it out. We have to reduce this function to 1. So here, to do that, I'll multiply by the inverse, and that will cancel out its function. So here I'll take this ratio, 18 over 32, and I'll do the sine inverse as well. Remember, what you do to one side, you must do to the other. So the value of my angle, theta, should equal the inverse sine of 18 divided by 32. So I'll just come down to my calculator. Remember, to do inverse, you have to hit the blue key first, so that's second sine. I'll make sure that I have my ratio correct. That's going to be 18 over 32. And there's my solution, 34.23. So here, the measure of this angle, we're going to say is 34.23 degrees. On number 4, it said, Lana's kite is flying 60 feet above the ground. The angle of elevation from where her hand is holding the string to the top of the kite is 48 degrees and 18 minutes. So this is a little bit different. If her hand is 5 feet from the ground, find the length of the string. So let's draw this right triangle. So we have a few things to consider here. All right, so the kite is 60 feet above the ground. So if this were the kite up here, we would assume that's approximately 60 feet. The angle of elevation from where her hand holding the string to the top of the kite is 48 degrees and 18 minutes. Now, you may not have seen this before, so let's do this over here. 48 degrees and 18 minutes. Here, think of degree like an hour. So the minutes are in reference to an hour. So think of this as 48 hours and 18 minutes. What we want to do to make this a decimal, we're going to say 48 degrees plus, and we're going to make this a fraction. So we're going to say 18 minutes, and we're trying to think, okay, how many minutes are in an hour? And that would be 60. So 48 plus 18 over 60 would give me the value of this degree as a decimal. So remember, when you have something like degrees, minutes, and even seconds, these are GPS coordinates. And we can make these decimals. So on my calculator, I'll go 48 plus, and then I can type in that fraction. So I'll do that by hitting the math key. So you see how fraction is all the way over here on the right? I'll just scroll one time to the left, and then on option 1, I'll hit enter, and then I'll type in 18 minutes over 60 minutes in an hour. So here I have this fraction. I don't want this as a fraction. I would rather have it as a decimal. So I'll come up here and hit math, and then I want the answer as a decimal. So I'll make option 2 and 48.3. So that's going to be the decimal in my triangle. So here I have 48.3 degrees. And we want the length of the string. So that would be this. Now, here's what you have to consider. The string is not on the ground. It says where she's holding it is 5 feet off the ground. So when we use our height, we don't want to use the 60 feet because 60 feet would assume the kite to the ground. But the string isn't on the ground. The string is in Lana's hand, which is 5 feet off the ground. So this height here, we're going to say is 55 feet. So now we have the opposite here, and we have the hypotenuse because it's across from the right angle. So we have the sine of 48.3 degrees equals the opposite leg, 55, over the hypotenuse. So here, when you're looking at something like this, and you have a fraction equals some value, if we wanted to, we could make this value on the left look just like a fraction. Because as we know, all whole numbers are fractions. They're technically over 1. So now I have this fraction equals this fraction. This is easy because this is now a proportion. So I can just cross multiply. So x times sine 48.3 is going to give me 55. Now I need to think, okay, how am I going to isolate the x? How am I going to get that by itself? Well, they're multiplying, so I'll divide here. So let me rewrite this so that I have a little bit more room. I have x times sine of 48.3 equals 55. And again, we said if they're multiplying, then in order to isolate, we need to divide. So here, I'll divide each one by sine of 48.3. So this is what I will type in, this fraction, on my calculator. So here, I'll hit math, I'll go over, I'll have my fraction here. Let me double check to make sure we have the right numbers. 55 divided by sine of 48.3. So 55 divided by sine of 48.3 degrees. And my answer is 73.66. So here, approximately 73.66. And this is feet. All right, let's do a few more. So I'll do one like 6 because I want you to have an example of one where you may have more than one triangle. So it says, Sarah is standing 35 feet from the base of a rock wall, watching her 2 sons, Max and John, climb the wall. The angle of elevation is 38 degrees to Max and 27 to John. How many feet above John is Max? So let's look what we have. So here we have the one giant wall. Sarah, she's standing here. She's 35 feet from the base, and she's watching the sons climb. So the angle of elevation is 38 degrees to Max and 27 to John. So 38 is larger than 27. So we're going to assume that this entire angle is 38 degrees. And then if it's only 27 degrees, oh, look at there, the ruler can do it. So here we have 27 degrees. This is the angle of elevation to John. So here we'll say, here is John. Spelled his name wrong, poor John. And then here is Max. So we want to know how many feet above Max is John. So we're looking for this distance. So here's what we're going to need. We're going to need to know how tall John is and how tall Max is. And then we can subtract the two. So it may be easier that when you're doing this that we just draw two separate triangles to begin with. So here we'll say, okay, this is 38 degrees. Here's how far Sarah is. How tall is Max off the ground? So we have the opposite leg, because that's directly across from the angle. We have the leg touching the angle, which makes that the adjacent. So opposite and adjacent give us tangent. So here, if we say tangent of 38 degrees equals the opposite over the adjacent. So remember what we did last time. I can simply make this a proportion. And now I can cross multiply. So this will be 35 times the tangent of 38 degrees equals 1 times x. So now this is what I'm going to type into my calculator. 35 times tangent of 38. So Max is going to be about 27.34 feet above the ground. Now we need to know how tall John is. So what I'll do is I'll just divide this. There we go. That's a little bit cleaner. And then we'll have our second triangle. And we'll go ahead and fill this information in. So it says John has an angle of elevation of 27 degrees. And the distance is still the same. So now what we're doing is we're just looking for John's height. So here, we're still using tangent because we have opposite and adjacent. So I will say tangent of 27 equals the opposite over 35. Again, we can just make this a proportion. So this will be 35 times tangent 27. Equals x. So that's what I'll type on my calculator. 35 tangent 27. That's going to be 17.83. So if we look at our work, Max is 27.34 feet in the air. John is 17.83. So if we want to find the difference between them, how much taller Max is than John, then we just need to subtract these. So on my calculator, we'll say 27.34. And we will subtract what we got for John, which was 17.83. And we get 9.51. So Max is 9.5 feet higher than John. So back at our problem here, when it says how many feet above John is Max, we can say that answer is 9.5. Now I know I'm jumping back and forth between rounding between the tenths and the hundred. It's really not going to matter. So long as your tenth number is accurate, I'm not overly concerned with what you have for the hundredths place. So those are your examples with elevation. I'm not going to do question 7. I normally like to leave some of the harder ones for you all to try those. So I'm going to leave 7 for you to do on your own. You can check the notes on the Canvas page for the solution. So depression is a little bit different. So depression, you see how you have the triangle here. So here's the triangle that's created when we're using angle of depression. The angle of depression is always on the outside here. So here's what we need to think about. You have two options to solve this. Since the line of sight is a straight line, let's redraw this so it's a little bit larger. So I'm going to get my ruler so that my lines are straight. So here I have, this is the line of sight. Here's the ground. Here is where the person is looking, and then here's the height that's created. So the angle of depression is always on the outside. Now, you have two options. These are two parallel lines, the line of sight and the ground. So technically that makes this a right angle. So whatever the angle of depression is, you could subtract that from 90, and that's going to tell you what this, we'll call it y, what the value of that angle is inside the triangle. Now, this is a step that a lot of people like to use. It works. To me, there is one that is a little bit faster. What if I instead, since we already have worked with angle of elevation, what if instead I just wanted to find this angle? The reason that I could find this angle is because x here is congruent to the angle of depression. Because if these are two parallel lines, this technically is a transversal. A transversal is any line that cuts through two parallel lines. You learned that in geometry. So these are alternate interior angles. So the angle of depression is always congruent to the angle of elevation. So we'll do this in a problem. From the top of a lighthouse 150 feet above sea level, the angle of depression to a boat at sea is 28 degrees. What is the horizontal distance? So here we have our lighthouse. So it says the lighthouse is 150 feet above sea level. The angle of elevation is 28 degrees. Now, here's what you have to think. The angle of depression is always right here. Here's the 28 degrees because we're looking down at an object. They want to know the horizontal distance to the boat. So to solve this, you have two methods. You may say, okay, since I know this is 90 degrees, 90 minus the angle of depression will give me the value of this upper right angle. So 90 minus 28 would give us 62. So you can solve the problem now, or you could simply say, well, I know the angle of depression has to be congruent to the angle of elevation because these are alternate interior angles. So in one way you would have opposite and adjacent, so you would use tangent. If you use the angle of elevation here, you still have opposite and adjacent. So here, let's go ahead and try to solve this. So if I have opposite and adjacent, then I'm using tangent. So tangent of 28 degrees should equal 150 over x. Now notice if you were doing 62, it would be tangent of 62 equals x over 150. So it's really not going to make a difference. So now if I set this up as a proportion and multiply, what I would have is x times tangent of 28 equals 150. Now here, since they're multiplying, we're going to have to divide. So on the calculator, I'm going to need to say 150 divided by tangent 28. So here I have 150 divided by tangent 28. And this gives me 282.1. And that's my horizontal distance. 282.1. So I could write that a little bit neater. Let's write it somewhere up here. So this horizontal distance is 282.1. So really you could think of this as the angle of depression is the angle of elevation. So let's look at number 9. The angle of depression from a helicopter to a landing pad is 34 degrees, 54 minutes, and 8 seconds. Remember, when it's set up like this, these are like GPS coordinates. If the horizontal distance from the helicopter to the landing pad is 1,200 feet, find the altitude of the helicopter. So this, we may want to think about it a little bit differently when we draw it. Because they give us a horizontal distance here. So it may be easier to think about this one as like this. And you could draw the triangle upside down. Now, it's not going to be any different if you still drew the triangle the same way we did on 8 or the way that we have been drawing it previously. So let's work on our angle of depression. Now I'm going to use it that way that was just drawn. If you drew yours this way, you're going to get the same solution. So I can prove that here. So we know the angle of depression is always on the outside. 34 degrees, 54 minutes, 8 seconds. So we need to convert this to a decimal. So we have 34 degrees plus, now this is minutes and seconds. Think of this in terms of hours. So this is going to be 54 minutes over how many minutes are in an hour? 60. Plus 8 seconds. Okay? Now, how many seconds are in an hour? Not how many seconds are in a minute. Everything needs to be converted to an hour. So I would just say 60 times 60, and that gives me 3,600. Remember, the calculator will do all of this. So on my calculator, I can say 34 degrees plus, this is going to be 54 over 60. Here, let me make this a fraction. Let me just clear this. 34 plus, we'll do a fraction. This is going to be 54 over 60 plus, and we'll go ahead and do another fraction. And that was going to be 8 over 60 times 60, which is 3,600. All right, this looks more confusing than it did originally. So let's go ahead and make this a decimal. So we'll click Math. We'll go down here to option 2. We'll hit enter twice, and there we go, 34.9. That's not too bad. So I'll come back to OneNote. So I have 34.9. This is my angle of depression. So they already tell us the horizontal distance is 1,200, not 12,000. Find the altitude of the helicopter. So I'm looking for the altitude here. Now, the first triangle that I drew, you know how I drew the triangle upside down? The altitude on the left is obviously going to be the exact same as the altitude on the right. So you're still looking for the height here, and you could have just called this horizontal distance up here 1200. You could use either one. I'm just showing you how it works. So remember, the angle of depression is the exact same as the angle of elevation because they're alternate interior angles. So if I was using the angle of elevation, I have opposite over adjacent. So that would be tangent. So I'll come over here and I'll say, all right, tangent of 34.9 is equal to the opposite x, because we're looking for the altitude, over the adjacent, 1200. Now I can cross multiply, so I have 1200 times tangent of 34.9. This equals x. So I'll type that in on my calculator. 1200 times the tangent, let's make sure I have my angle right, 34.9. And I get 837.13, or you could say 837.1. So here this would be 837.1 feet in the air. So here for 10 and 11, Henry is sitting in a tree 32 feet above the ground watching a deer. If the deer is 57 feet from the base of the tree, find the angle of depression from Henry to the deer. So here, Henry is sitting in a tree 32 feet from the base. Oh, not this. There we go. He's 32 feet above the ground. The deer is 57 feet from the base. All right, so I can't draw a deer, so we're going to say, oh, there's the deer. And we'll give him like a set of legs, maybe a face, maybe some antlers. All right, that's the best I got. There's your deer. Now, they want to know the value of the angle of depression. Now, remember, you cannot forget this. The angle of depression is never inside the triangle. So I always tell my students, the angle of depression is always on the outside looking in. So here is the angle of depression. He's always on the outside looking in. That's why he's depressed. Wah, wah, wah. So you could find this angle here, but you have to remember that that's the exact same as the angle of elevation. So really that's what we're looking for. So if I base it off the angle of elevation, I have opposite and adjacent, so this would be tangent. Since we know we're looking for the angle, this is going to be inverse tangent. And we'll show that math right over here. So this is going to be tangent of this angle is going to equal the opposite 32 over the adjacent 57. Now, we don't want tangent of the angle, we just want the value of the angle. Well, the way you undo this tangent is to multiply it by its inverse. Remember, sine, cosine, and tangent, these are not simply, we're not multiplying by specific numbers. These are functions. So here, to reduce a function to 1, so that I have 1 times this angle, you have to multiply a function by its inverse. So now, these cancel, they go away, and I'm left with the angle is equal to the inverse tangent of 32 divided by 57. So I'll go to my calculator, and I will say inverse tangent of 32 over 57, and that gives me 29.3. So this angle is 29.3 degrees. So here I will leave 11 and 12 for you to do. Remember, I like leaving a couple of questions just so that you can work through them. If you need the solutions, they will be found in the Canvas page.